AWS CloudFormation Express mode can report a deployment complete up to 4 times faster, but the resources may still be stabilizing in the background. So the green check arrives faster, but it means something different. Apache Spark 4.2 adds native vector operations, allowing some AI data workloads to stay inside the platform teams already operate. GitLab says that AI is making developers faster at producing code, while review, testing, governance, and deployment struggle to keep up. And a platform team at Sevdesk has a question for anyone rolling out new controls. Will your internal users hate you by the time you are finished? Put those together, and the theme this week is local optimization. Making one part of the system faster does not guarantee the whole system gets better. Sometimes it just moves the waiting, risk, or ownership problem somewhere else. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, the show about the DevOps, SRE, cloud, platform, and security stories that matter when you are the person keeping the thing running at 3 a.m. For the weekly story list and source links, check out oncallbrief.com. For full show notes and past episodes, head over to shipitweekly.fm. This week, CloudFormation Express Mode, vector functionality in Spark 4.2, GitLab's warning that AI is accelerating code faster than software delivery, and minimum viable governance for platform teams. In the lightning round, OpenShift security updates, a GitHub Actions outage, Cloudflare dropping some post requests, and GitHub code quality becoming generally available with billing attached. And we close with Reed Savage on the difference between what a capable team could do and what it should do. Let's get into it. First up, AWS introduced CloudFormation Express Mode. AWS says it can reduce deployment completion time by up to 4 times in some workflows, but it does not necessarily make the underlying resources provision 4 times faster. It changes when CloudFormation declares the operation complete. In standard mode, CloudFormation applies the configuration and waits for resources to pass stabilization checks. Express mode reports completion once the configuration has been applied, while the resource may continue becoming operational in the background. AWS showed an SQS deployment dropping from 64 seconds to around 10 seconds. That is meaningful when you are repeatedly changing and testing infrastructure, especially for AI agents that are generating, deploying, and correcting configurations. But deployment status is a contract. Pipelines, dashboards, agents, and engineers all make decisions based on what complete means. What happens immediately afterwards? Do you run integration tests, deploy an application, shift traffic, start another stack? With Express mode, those steps may need their own readiness checks. CloudFormation can be finished while the resource is not ready. Express mode also disables rollback by default, although teams can turn it back on. That makes sense for development, where you may not want every failed experiment followed by a long rollback. In production, though, faster confirmation without readiness validation, monitoring, or rollback could let the pipeline move ahead too early. The takeaway is not that Express mode is unsafe. It looks useful. The takeaway is that teams need to separate 3 states they often treat as one. The configuration was accepted. The resource finished provisioning. And the application is ready for users. For development, testing, and agent-driven workflows, the faster loop could be a major improvement. For production, the pipeline needs to understand exactly what that green check now means. Faster confirmation is useful. Confirmation is not readiness. Second story, Apache Spark 4.2 adds native support for more vector-oriented operations. Spark SQL now includes functions for similarity, distance calculations, normalization, and vector aggregation. It also adds nearest by, a top K ranking join for matching rows based on similarity or distance. That supports workloads like recommendations, entity matching, candidate generation, and offline retrieval. This does not mean Spark replaces every vector database. A specialized system serving low latency application requests is solving a different problem. But not every vector workload is an interactive search request. Sometimes the data is already in Spark. Sometimes you are evaluating embeddings, enriching large data sets, or generating candidate lists in batches. Moving that data into another platform means another credential flow, network path, scaling model, upgrade process, and bill. So the first question should not automatically be, which vector database should we add? It should be, what does this workload require? Is it online or offline? What latency and freshness do we need? Do we need a serving API? Or can the work stay inside a platform we already operate? Large similarity operations can still be expensive. Teams still need to think about scale, partitioning, and compute costs. But Spark 4.2 reflects a broader shift. Established platforms are absorbing more AI-oriented capabilities. Sometimes a specialized system is justified. Other times, the best new platform is the one that you do not have to introduce. Third story, GitLab released its 2026 AI Accountability Report based on a survey of more than 1,500 developers and technology buyers. 78% said developers are writing and committing code faster with AI. But 85% agreed that the bottleneck is shifting towards review and validation. That makes sense. Software delivery is a chain of queues: implementation, review, testing, security, deployment, operations. AI may accelerate one part, but if the next stage has the same capacity, work piles up there. If developers create twice as many pull requests, but the organization has the same number of reviewers, reviewers get slower. If an agent generates Terraform in 5 minutes, but every plan still needs a senior engineer to interpret the blast radius, that engineer becomes the queue. And if more code reaches production without better validation, on-call becomes the final quality gate. Producing the implementation faster is a real gain. But what happened to lead time, rework, review quality, and change failure rate? GitLab also found a gap between confidence and traceability. Most respondents believed they could quickly determine whether AI-generated code contributed to an incident. But among organizations that had experienced an incident, roughly a third could not actually determine it. That leads to 3 useful questions for any AI-generated change. Where did it come from? What was it intended to do? And who owns the result in production? Those are not just compliance questions. They are incident response questions. When something breaks, teams need to know what generated the change, what context it had, what validation ran, and who accepted responsibility. The exact percentages come from vendor-sponsored research, but the broader point is sound. Generating the artifact is getting cheaper. Understanding, validating, and operating it is not getting cheaper at the same speed. The goal is not to maximize code entering the pipeline. The goal is to safely deliver useful changes through the entire system. A faster coding agent does not automatically create a faster engineering organization. Fourth story. There was a talk called Road to Compliance: Will Your Internal Users Hate Your Platform Team? The story comes from Sevdesk, where the platform team needed to improve cloud security, spending, and resource governance. The bad version of that rollout is familiar. The platform team creates a long list of requirements, gives developers a deadline, and threatens to block deployments. The controls may be technically correct, but the rollout treats governance only as a configuration problem, when it is also a change management problem. One issue at Sevdesk was inconsistent resource tagging. Rather than immediately blocking deployments, the platform team first built visibility. They used AWS Config and Security Hub to find resources, connected findings to repository and CI information, grouped notifications to avoid flooding teams, and sent feedback through Slack. The rollout followed 3 stages: inform, soft enforce, then enforce. They call this minimum viable governance. The idea is not to weaken standards. It is to begin with the controls that address the company's most important risks and introduce them in a way that teams can adopt. If Security Hub contains thousands of findings, treating all of them as equally urgent does not create security. It creates noise. Without prioritization, the platform team becomes the enforcement layer for everybody else's queue. That is how a paved road starts feeling like a toll booth. The deeper lesson is that the platform team's product is not the policy. The desired product is changed behavior. A failed deployment does not teach someone how to fix an issue. An automated message is not useful unless it reaches the correct team, provides context, and explains the remediation. Important controls should eventually become real controls. But the sequence matters. Build visibility. Find ownership. Prioritize by risk. Give teams useful feedback. Then, enforce what has already been explained and supported. Internal users are still users. You can win the policy argument and still lose the platform. Quick lightning round. First, OpenShift Container Platform 4.22.5. Red Hat rated this an important security advisory and recommends OpenShift 4.22 users update when the release reaches their channel. The reminder is simple. Supported does not mean current, and a functioning cluster is not necessarily a fully patched cluster. Second, GitHub Actions had a disruption on July 13th. At the peak, 30% of Actions jobs failed to start. Pages builds and Copilot Cloud Agent sessions were also affected because both depend on Actions. GitHub traced the issue to an autoscaling change using outdated capacity thresholds. The configuration was valid. Its relationship to the live system was wrong. Validation needs current operational context, not just correct syntax. Third, Cloudflare had an incident where some post request did not reach customer origins correctly. The takeaway is to test more than get. A homepage can load, while logins, purchases, API writes, and webhook deliveries are failing. Monitor the actions that users actually depend on. Fourth, GitHub code quality is now generally available. It includes CodeQL analysis, AI-assisted detection, quality gates, and Copilot autofix. It is also now a paid product at $10 per active committer per month, plus some usage and actions costs. Billing began automatically for organizations that had it enabled during preview. Preview features can become production dependencies and production bills. Know what has been enabled before the invoice explains it for you. The human closer this week comes from Reed Savage at Honeycomb. Their article is called Could versus Should, the first year managing an SRE team. Reed says SRE teams and engineering managers have something in common. There are many things they could do, but only some are things they should do. Separating the two requires context and comfort with ambiguity. During their first year managing Honeycomb's SRE team, Reed sometimes stepped too far away from technical decisions because they wanted the team to maintain ownership. But staying completely silent was not always useful either. Their experience could identify roadblocks or add context. The lesson was not that managers should take over. It was that they need judgment about how to participate. Sometimes you make the call. Sometimes you recommend a direction. Sometimes you offer context. And sometimes you stay quiet. The same applies to SRE ownership. A capable SRE team can solve many problems, but capability alone does not determine responsibility. Will owning this work create reusable leverage? Will it improve reliability across the organization? Or will it make one strong team permanently responsible for everyone else's ambiguity? That connects back to every story this week. CloudFormation can report completion faster, but should this production workflow use it? Spark can perform more vector work, but should this workload live there? AI can generate more code, but should all of it immediately enter the review queue? The platform team can block every non-compliant deployment, but should blocking be the first interaction developers have with the policy? Capability expands the decision space. It does not make the decision. Good engineering increases what is possible. Good leadership decides what is useful. And good teams keep asking whether the thing they could do is actually the thing they should do. That's it for this week of Ship It Weekly. We covered CloudFormation Express Mode, vector operations in Spark 4.2, AI accelerating code faster than delivery, and minimum viable governance for platform teams. Plus, OpenShift updates, a GitHub Actions autoscaling failure, Cloudflare dropping post requests, and GitHub code quality becoming generally billable. Follow or subscribe wherever you are watching or listening. And send this episode to someone trying to fix an organizational bottleneck by making one tool run faster. You can find the weekly story list at oncallbrief.com and the show notes and past episodes at shipitweekly.fm. I'm Brian Teller from Teller's Tech. Thanks for listening. And remember, faster is not the same as finished, and could is not the same as should.